gonna start building these up here. Everybody looked at us pretty much got the right idea. The first one.
That's a high end. I know, I was in when I got negative 3, and then something,
So you guys got for the first one, 7, 1, 2, 3? 71% of women would have a bone density above 2.5 grams per square centimeter. These are real numbers, by the way. I looked them up a while back. I'm sure, you're not quite at the age that you're worried about that. But normally it is women that are affected by low bone density because you guys have your calcium leached out by certain things. This just happens. Calcium vampires. So part B, I really, once you do a few of these, you start to realize all this work is the same. It's down here. It's exactly the same except for one thing. Can't use 0.71. You've got to use the new one. That's the only difference. How do I know when to do that? That's what kills people. Is I know what to do. I just don't know when to do it. Because I took a sample, and I'm asking about the sample mean. Am I always going to make those bold and underline? Hell no. But for right now, I'm trying to show you that's what you look for to tell when to do that. So the very first thing I do is I change that. Let you guys keep working for a little while. And the only difference in the work of Part B, all the same exact words, same exact picture. Just divide by the spread of groups of size 38. Now, why does this make sense? Because if I take a group of 38 women, the picture, to be honest, here's what the old picture looks like. The new picture, there's going to be a lot more here in the middle. Because the larger the sample I take, the more likely it should be that they're closer to the real mean. So then when I ask you, how much is above here? Well, there's going to be a lot less below there. So there should be a lot more above there. There's going to be a lot less way out to the extreme. So sure enough, there's a lot more. Very few women, groups of 38 women, would have an average that low or lower. Please let me make sense. I'm going to do 2A and B real quick because that's old news. One infant. Old news. of the sample size.
Okay.
This, by the way, is the type of.
Okay. So the mean is the same?
I think at some point I was going to change it, and then I decided not to.
Okay.
That's what I'm getting for part B there for the how long Florida infants born now are going to live. So I got these Z-scores. Did you guys get those Z-scores?
Yeah.
233, because you got to round that up, and negative 114. So when you look up negative 114, I get 1271. I'm going to look up negative 233. 0.009. And to subtract those two, I'll just get the area in the middle of them. So what do you get?
1117.
Who?
1117.
1172. So just under a 12% chance that an infant born now in Florida will live to be between 62 and 71 years old. So those two have got to be bread and butter. What do I mean by that? It's an old saying. They've got to be your go-tos. They've got to be your, oh yes, give me more of these. This is easy, this is easy, this is easy. Even this now, hopefully, you guys are starting to see what you got to look for. I took a sample, and I'm asking about the sample mean. So then what's got to change? Standard deviation. It's going to be what it used to be. 87, 11. So people can put all kinds of weird shit in there. They put the mean in there, they put whatever. It's going to be the old standard deviation divided by the square root of your sample size. What do you guys get for that? I like it, so I'm going to do 0.815. If you do 8.148, it's even better. It's going to be at least 3. So it's going to be the same picture, it's going to be the same mean, it's going to be 79. I want it less than that, so I still make a z-score out of it. The only real difference in the work between this and part A and number 1 is to divide by the new standard deviation. Good Lord, John. So that's what you get for the z-score there. So when you look that up, you get good old 1949. So there used to be 46%, there were 46% individual infants that I'd expect to live to be less than 79 years old. When I take a sample, there's going to be a lot less out there because there's going to be more closer to the mean. There's only About 20%. That's out there that far. There's more of them are going to be closer to the mean. Okay. I think that's it. So we just did all of chapter 7. Well, which is 7:1 and 7:2. Don't worry about 7:2. 7:2 is not part of what we were. If I remember correctly. We talked about it on math. Yeah, 7:2's out.
Oh, that's someone.
For a little bit, I'll upload the video. Yeah. It has to equal 1, but if it's close, when we say it's close enough, because it's going to be just rounding.
I could have sworn you told me to do
Not
that,
quite.
like,
But you have to say it should be 1,
a year ago.
but it's close enough.
Sometimes
You add this up, they're actually going to yeah. Do you have a minute? If you're going to run back to the office and put that spreadsheet agreement. Either way, beat me there and hang out.
Yeah, I don't know where it is.
Yeah.
I just go with you.
That's probably a good idea.